Hello everyone. In this class, we will discuss the injectivity and surjectivity for the function f is from z to z given by f of x is equal to x square. So the injectivity means every element from the domain have unique image in the codomain. But now here the domain and codomain both are integers. So in an integer set of integers, if I draw properly, so it includes 0, -1, -2, -3 and so on. Similarly 1, 2, 3, 4, 5 and so on. And the codomain is also set of integers. So in this side also 0, -1, -2, -3, 1, 2, 3 and so on. So if we give input as a 0, the 0 square will map to 0. But if we take input as -1, so the square of -1 is nothing but +1. Similarly, if we put 1, then 1 is also mapping to 1. So we have two different elements, 1 and -1. So the answer of f of 1, that is equal to 1, and the answer of f of -1, that is -1 square, that is also 1. Means two different element, 1 and -1, have the same image. So f of 1 is equal to f of -1 is equal to 1. That means two different elements are mapping to the same number 1. That means this function is not 1 1. Okay, so if it is not 1 1, then we can give the counter example also. For example, here we have given, if you want to write down proof, then let x1 and x2 belongs to domain, that is integer z, such that f of x1 is equal to f of x2. Two elements we have taken, any two elements from the integers, such that their images are equal. So that means x1 square is equal to x2 square. So if we take this x2 square this side, it will become x1 square minus x2 square is equal to 0. So if you apply a square minus b square, so it become x1 minus x2 into x1 plus x2, that is equal to 0. So from here we will get either x1 is equal to x2, or we will get x1 is equal to minus x2. So we are getting two conditions, so which is not possible. If we are getting only this one, x1 is equal to x2 possibility, then only we can say it is 1 1. But we are getting this also, x1 is equal to minus x2. Okay, so means two different elements are mapping to the same image. So that means this is not 1 1. So therefore f is not 1 1 function. If we look at the graphically, so this is our domain, represents by x-axis integers, and on the y-axis that represents codomain, that is also z. Okay, so if I plot the graph of this 0 map to 0, so one point we can consider 0 comma 0. If we take 1, then 1 is mapping to 1, so this point. If we take 2, then 2 is mapping to 4. Okay, and if we take negative 1, then that also maps to 1. Negative 2, that also maps to 4. Okay, so our graph will look like this kind. So we can see that here 1 is also mapping to 1 and -1 is also mapping to 1. So two different elements, -1 and 1, have the same image 1. Okay, so by graphically, the trick is, if you draw any parallel line to the x-axis, and if that cuts the graph at more than one point, then that function is never to be 1 1. Okay, so this is the graphical method. So this function is not 1 1. Now let's check about onto. So this function is not onto also, because if we look at the range of this function and codomain, so the range of the function, if you see, domain is all the integers 0, 1, 2, 3 and so on, negative numbers also. Codomain is also integers 0, -1, -2, -3, 1, 2 and 3 and so on. So if you take 1, the answer is 1. If you take input as 1, sorry, for 0 and 0, input if you take 1, then we will get answer 1. For 2, answer 4. For -1, answer is 1. So our range set contains only the positive values including 0, 0, 1, 2, 3, 4 and so on. And our codomain is nothing but set of all the integers 0, plus or minus 1, plus or minus 2 and so on. So our codomain, which is not equal to the range set. So if codomain and range are not equal, then we are saying it is not onto. Okay. So this function is not onto. Otherwise we can give counter example and we can write like this. In the domain set we have all the numbers 0, minus 1, minus 2, 1, 2 and 3. Here also like this number is there 0, negative 1, negative 2, 1, 2, 3. So 0 is mapping to 0, 1 is mapping to 1, 2 is mapping to 4. So that means 0 is remaining here without mapping. Okay, means there is no number in the domain. So if we take the square of that number and we will get 3 in the integer. Okay, there is no such x such that the square of that number, the answer will give you 3 in the integer. Okay. So we can write down, it is clear that f of root 3, which is square of root 3 is 3, means there is no number. If you find out that number, then it will become root 3, but root 3 does not belongs to integer. So there is no number in the domain f such that their image is 3. So we can say f is not onto. So this function f from z to z given by f of x is equal to x square is not on 1 and not onto also. 1 is also not there and onto is also not there. Okay, I hope this question is clear to you. Thank you everyone.